Imagine, for a moment, that your entire existence, your thoughts, memories, and perception of reality, is an illusion. Not because of a glitch in some grand simulation, but because you are nothing more than a fleeting fluctuation in the vast randomness of the universe. You are a self-aware, fully conscious mind that has spontaneously emerged from chaos, existing just long enough to question your own reality before dissolving back into oblivion. This bizarre yet deeply profound idea is known as the Boltzmann Brain paradox, a thought experiment that shakes the very foundations of cosmology, thermodynamics, and our understanding of reality itself. To understand Boltzmann brains, we must first explore the ideas of Ludwig Boltzmann, 1844 to 1906, an Austrian physicist who made groundbreaking contributions to statistical mechanics and thermodynamics. Boltzmann's work explained how the macroscopic properties of gases, such as temperature and pressure, arise from the microscopic motion of individual particles. One of his key contributions was the Boltzmann entropy formula. S equals K lane W, where S is entropy, K is Boltzmann's constant, and W is the number of possible microscopic states that correspond to a given macroscopic state. Boltzmann was obsessed with understanding the arrow of time. Why does the universe seem to move from order to disorder, from low entropy to high entropy? His answer: because there are vastly more ways for a system to be in a high entropy, disordered, state than in a low entropy, ordered, state. But this led to a troubling implication. If we wait long enough in an infinite universe, random fluctuations should occasionally create ordered states by pure chance. And if that's true, then shouldn't our entire universe itself be a random fluctuation? Boltzmann suggested that our universe, with its relatively low entropy, might itself be a rare statistical fluctuation from a much larger and higher entropy cosmic background. This would mean that, given enough time, smaller fluctuations, such as a single self-aware brain, should be far more common than the vast, structured universe we observe. Here's why. 1. Entropy favors disorder. In an infinite or extremely long-lived universe, randomness dominates. Given enough time, the universe can randomly fluctuate into any possible configuration. 2. Smaller fluctuations are exponentially more probable. A full-fledged universe with galaxies, stars, and planets requires an immense reduction of entropy, which is highly improbable. But a single conscious brain, briefly fluctuating into existence complete with false memories and a sense of reality, is far less improbable. 3. The unsettling conclusion: if most observers in the universe are actually Boltzmann brains, rather than beings that evolved naturally in a structured universe, then our perception of reality is likely an illusion. If Boltzmann brains outnumber naturally evolved observers, then the odds suggest that we are Boltzmann brains, not beings living in an actual, long-lasting cosmos. But this conclusion is deeply unsettling because it contradicts everything we observe. Our universe appears to be governed by consistent physical laws. We observe a vast cosmos full of galaxies, suggesting an ongoing, structured evolution. Our memories and experiences appear continuous, not ephemeral. This presents a paradox. If Boltzmann brains are the most statistically likely observers, why do we appear to live in a structured, lawful universe? Scientists have proposed several ways to resolve this paradox. 1. The finite universe hypothesis. One way to avoid the problem is to argue that the universe is not infinite or eternal. If the universe has a definite beginning and end, then it doesn't persist long enough for Boltzmann brains to form in significant numbers. The observed universe could be the result of natural cosmic evolution rather than random fluctuations. 2. The cosmological decay solution. If the universe has a finite lifespan due to a phenomenon like the Big Rip or vacuum decay, then there wouldn't be enough time for fluctuations to create more Boltzmann brains than biological observers. 3. The anthropic argument. The anthropic principle suggests that we can only observe a universe where intelligent beings like us can evolve. In other words, we shouldn't be surprised to find ourselves in a structured universe because, in the countless other possible universes where intelligence never arises, there would be no one to ask these questions. 4. Quantum mechanics and the many worlds interpretation. Some theorists argue that quantum mechanics may play a role in resolving the paradox. The many worlds interpretation suggests that every possible outcome of a quantum event actually occurs in a branching multiverse. This could mean that naturally evolved observers like us vastly outnumber Boltzmann brains across the quantum multiverse. If Boltzmann brains exist, they raise profound philosophical and existential questions. Can we trust our memories? If our consciousness is a fleeting fluctuation, then our past could be an illusion, fabricated by chance. Is the universe real? If the laws of physics are just temporary constructs in a Boltzmann brain's mind, then reality is no more than a mirage. Are we alone? If intelligent life is just an unlikely byproduct of random fluctuations, then advanced civilizations may be far rarer than we assume. Some scientists take comfort in the fact that if we truly were Boltzmann brains, we would expect to observe a chaotic or nonsensical universe. The fact that our world is highly ordered and follows predictable laws suggests that we are more likely evolved beings rather than random fluctuations. For now, the prevailing view in physics is that Boltzmann brains are a theoretical curiosity rather than a pressing existential crisis. Our structured, evolving universe appears to be far more likely than a scenario dominated by fluctuating minds. However, the very fact that such a paradox arises from our understanding of entropy and probability forces us to confront the fragility of our assumptions about reality. The universe remains a vast, mysterious place, and ideas like Boltzmann brains remind us that, in the grand cosmic scheme, even our own consciousness might not be as secure as we think. In the end, whether we are real or just a temporary flicker in the void, one thing remains true. As long as we can think, question, and wonder, the mystery itself is worth exploring.